Bismillahirrahmanirrahim. Today we will start our 8th lecture of course Calculus 2. In today's lecture we will study gradient of a scalar point function. First of all, we should understand that what is the scalar point function, and after that we will see that how can we find out its gradient. So basically if we have a space on the xy axis, if we have some region of space like this and we call it the R. So on this, when we take a small area from it, that will be its scalar point function. We will represent it by u and we can take the axis on it. As on these axes we can take the xy, we can also take it on the 3 axis. If we take the scalar point function in x, y and z axis, then we can find its gradient by the formula del u. We can also write it as grad u. We have to find out the value, we have to put the value of the del, that is our del operator or the vector operator. Partial by partial of x in the I hat axis plus partial by partial of y in the j hat axis, and then plus partial by partial of z in the k hat axis. And it will be the value of the del, and then we will multiply it with the u. Now we will solve an example that how can we find out the gradient. We have to find the del u, and the value of the u is x square y square plus xy square minus z square. And the other values of the x, y, z are 3, 1 and 1. So by using our gradient formula, del u is equal to partial by partial of x in the I hat direction plus partial by partial of y in the j hat direction plus partial by partial of z in the k hat direction, and multiply with u. So del u is equal to, now we have to multiply the u inside. So it will be u in the I hat plus partial by partial of y, and u will be multiplied, and same for the z axis. Now we will put the value of the u, partial by partial of x, and the value of u given to us is x square y square plus x y square minus z square. And with y, partial by partial of y and the value of the u, then plus partial by partial of z and the value of the u. This is how our expression will look like. And now we will take the partial derivative with respect to x, y and z. So while taking the partial derivative with respect to x, our answer will be 2x y square plus y square, and with z it will be 0. So plus, and with respect to y it will be 2x square y plus 2xy, and with respect to z it will be 0. And after that plus, with respect to z, this expression will be 0 and this expression will also be 0. We will only take the derivative of z. So it will be minus 2z. We have to write our x's here, I hat, j hat and k hat. These are our I values, I hat and j hat, and this is our k hat value. Now we have to put these values inside our expression. So our x is equal to 3, y is equal to 1 and z is equal to 1. So del u is equal to 2 into 3, 1 square plus 1 square. This is the I hat direction, and then plus 2 into x value is 3, it will be 3 square into 1 plus 2 into 3 into 1. This is our j hat direction, and then for the z we have the value 1. And this is our k hat direction. Our final answer will be 7 I hat plus 24 j hat minus 2 k hat. This is our del u value, the gradient of scalar point function. In the part 2 of this video, we will solve the one more example in which we will see that how can we find the gradient of a scalar point function.